Okay, hello everybody. Welcome to today's event on the networking channel. We will be having an event today called Large ISPs. How do they work? What are the challenges they face in the engineering and CS skills that they need? It's going to be organized as a panel, and it will be led by three really incredible experts on ISP communication. We have Jason Livingood, who is Vice President of Internet Systems Engineering at Comcast. He served as co-chair of an Internet Engineering Task Force working group, as well as several other working groups, and is the author of a number of RFCs. He has several patents. We have Amreesh Phokeer, who is currently working as an internet measurement expert at ISOC, also an internet measurement and data expert at the Internet Society, co-chair of the Afrinic Measurement Working Group. He's also a rail runner, a scuba diver, and a busy father. We have Yong, who is currently a full professor at Tsinghua University, the Deputy Director of Network Technology Institute, the council member of the China Communication Standards Association. He has directed several national R&D projects, and he has over 40 national patents and has received numerous awards. Before we start, we also want to mention that the networking channel is a series of talks happening every 2 weeks, and 2 weeks from now, we will have a talk on low Earth orbit satellite mega constellation systems, which will be also a panel comprising experts from both industry and academia who will discuss how these systems work, as well as their unique system challenges and avenues for research. Should be very interesting. It'd be great if you can attend. And with that, we're going to start the panel for today. And one of our goals is to keep things informal. So please feel free to join in and guide the conversation towards your interests. You can interact with the panelists. You can ask questions on the Zoom using the Q&A feature at the bottom of your screen. You can also enable closed captions if that's helpful for you to see what's being transcribed as text on your screen. You can also enable translations if you would like to see our words translated into your preferred language. And I'm now going to turn things over to Edmundo, who will be asking the first question of the panelists.
Oh, thank you, Matt, and thank you all of the panelists for their time. Everyone is very busy, so thank you very much. And we start for the following question. All the panelists will have the opportunity to comment on it, and it's the main question of the panel. In your view, what are the primary challenges faced by ISPs today? So what are the significant network challenges that you confront or that you see today? So we are gonna start, randomly select our speaker. To my right, Jason. Please, Jason, can you start with that?
Sure, thank you. So in terms of the most significant network challenges, I think it's a few things. One, in-home Wi-Fi network performance is really the primary bottleneck for users these days, but it's often outside of the control of the ISP, and the user often connects it to ISP access network performance. So that's one of the challenges. And some ISPs, many ISPs are now creating home network products that can help the customer with more of that, but that's certainly one of the issues. The other is that there's this sort of ongoing, I think obsession would be too strong a word, but sort of excessive focus on really just speed or bandwidth as the solution to everything, particularly from a policy maker standpoint or a market demand standpoint. But as we get increasingly more and more people with gigabit connections, there's really this declining marginal utility of bandwidth, and there are these other factors that emerge. And one of the biggest ones is working latency, and it's one that unfortunately a lot of people don't understand. And even within ISPs, people still think about QoS and prioritization, which is really about when you have scarcity, not when you have abundance. And so we're really seeing latency or working latency emerge as a key quality of experience factor. And so that's another one. And then finally, I would say network connectivity to edge platforms, the places that people go for content, whether those are cloud providers, CDNs, et cetera. Those interconnections are getting ever more local, and that will drive eventually to things like edge compute and edge caching and these kind of things. But there's a bit of a transition that's happening now to have those things become sort of hyper local, if you will.
So thanks a lot, Jason. And we're going to start from my left in the screen. Yeah, please, Yong, could you present your slides? I guess you have a couple of slides on that topic.
Yes. So thank you all. You can see my slides, right?
Perfect.
Yes. So I'm so glad to be here, and I'm also from Sonata, which is maybe the largest research and education network. So in our experience, I think maybe we need to consider the very high availability and reliable of the backbone network. So there are these risks on the network optimization or even to deploy some new services. So the risk is quite significant. For example, even we consider the robustness of the IP backbone network, that is the utmost importance since even a minor issue can have a tremendous impact on the above layer services. For example, as you may know, network slicing is rarely used in the core network, but even with this kind of straightforward high bandwidth forwarding approach, the network operational problem can still arise. Maybe this is due to the considerable gap between the IP backbone network and the upper layer services, coupled with the complexity of these services. So this kind of things make it very challenging for operators to have the comprehensive understanding of the entire picture. So I think maybe the network configuration verification is very valuable. But the verification is not only on the to ensure the connectivity, maybe, but also need to consider the performance. So even it is valuable even to guarantee 50% performance, for example, the bandwidth estimation. So for some kind of new configurations. But however, there are still significant risks associated with the network configuration automation. So that is I think the basic requirement. And then we also have some challenge on the network optimization. For example, when we deploy IPv6, we found that the QoE of the applications may degrade very much. For example, when some of the DNS database has a lack of synchronization, some website may have inconsistent support for IPv4 or IPv6. So when we use some video applications, the application may generate a very large number of connections, and some of the connection may not support IPv6. So that can lead the degradation of QoS for the applications. And so I think maybe the cross-layer coordination is quite important for the network optimization. But the ISP has only very limited understanding of the application QoS. For example, ISP often have very limited visibility into the application level QoE. So that is very difficult for them to optimize the service based on their specific application requirement. And another example could be the optimization for the cloud-based 4G or 5G core networks. You know, the ISP expert responsible for such designing and managing core networks may not have the in-depth knowledge of the under IP carrier network. So that is very difficult for the cross-layer coordination. And additionally, the innovation on large-scale network are very difficult to deploy. You know, some new point-to-point technologies like optical communication and interface bandwidth upgrades are relatively easy to deploy. But network technologies that require interaction among multiple devices or even in this large scale network very difficult to deploy. So I think that is a very important issue to launch or to deploy new technologies we need to think about. And there are some more challenges. For example, DDoS attack is still a persistent problem. The bandwidth or interfaces and the cloud sessions are also remain vulnerable. And some new types of DDoS attacks occur or even with a very large volume, like a terabit BPS. And also the deployment of security protections for 5G MEC is lacking, where 5G device has low latency, high bandwidth capabilities, and this kind of IoT device with very few protections will be easy to be bots, right? So this kind of asymmetry of defense cost make a high bandwidth defense very quite difficult. And also the network of configuration is too cautious and prolonged. You know, in order to maintain this kind of very high availability for the backbone network, the service provisioning time is pretty prolonged in large scale network. So dealing with this kind of pulse attack of the DDoS is quite difficult with this kind of prolonged configuration. So I think that is, in my opinion, the most challenges issues. Thank you.
So thank you very much. It was nice to see the view of both of you. And now we are going to our third panelist, Amreesh is. I hope I pronounced it right, the name. As a Brazilian. Okay, so can you please
Sure, thank you, Edmundo, and hi everyone. Yeah, I would like to give maybe a little bit of a different perspective to talk about the challenges that ISPs are facing in Africa, where I have I would say the most of my experience. So first of all, Africa is a large continent with you have high performing countries such as Kenya, Nigeria, and South Africa, where you have a very well developed ecosystem. You have ISPs, and a lot of traffic is being exchanged locally, and then you have a lot of content providers and CDNs providing their caches on the local peering fabric. So in these countries, and especially in the urban settings, internet quality and internet access is quite comparable to some more developed countries. But there are many other countries in Africa which are facing a lot of challenges, whether it is challenges with affordability of access to international capacity. Some countries are landlocked, so they have to rely on their neighboring countries to have access to terrestrial fiber first, and then have access to subsea cables. And relationship between countries are not easy, and they have to negotiate sometimes at a country level, and it can add up a lot in terms of costs when landlocked countries have to deploy internet services. On top of that, the fact that a lot of small countries, when they need to buy equipment or to upgrade their equipment, they usually have to wait quite a long time because they do not have the same purchasing power as other countries. So the provisioning of equipment has been an issue, and especially with the chip shortage and everything. So this has had an impact on how ISPs in Africa are scaling. I would say the other factor affecting ISPs in Africa is the shortage of manpower, right? I guess we will talk about this later. a bit more in details, but it is a big problem in Africa, where a lot of African engineers are either poached by other countries because maybe the financial benefits are much better. But there is also the disconnect between what local universities and local training institution can offer. So this creates some sort of gaps in terms of maintenance of the technical infrastructure of the ISPs, which makes the life of network operators quite difficult on the overall. Thank you.
So, thanks a lot, Amreesh. I have already a lot of questions for each one of you. It's interesting, but the audience has also a lot of questions. So I ask Matt, can you please select a few of those questions and let's have the audience participating here.
Yes, and audience, please keep the questions coming. These are great. So one question is about bandwidth. So it sounds like bandwidth may not be an issue so much in the United States or certain parts of the United States. Could you speak to is there a big challenge with providing decent connectivity and bandwidth to people outside the major metro areas in the United States? In other countries, we lag so far behind Europe and some other places. And also related to that, what do you all think of community networks and the extreme opposition to those by incumbent edge ISPs? Do any of you have thoughts on those questions?
This is Jason. I can answer to some of those things. The first, I would say, in terms of the opposition to government-owned networks, I think that's something that is naturally changing primarily as a result of all of the US BEAD grants. You've got $45 billion or more going to state-administered grants, and in many cases, those are going to government or community-owned networks. And so I think you'll see in a few years, first, obviously, some of these are now getting new funding, and secondarily, you'll see that the track record, that develops, based on those networks. So I think that's changed, a little bit because of the funding that's been thrown at this, and we'll see. In terms of bandwidth in metro areas versus, sort of exurban, suburban, and rural areas, that's definitely an issue. It sort of depends on the technology, but with new networks like low Earth orbit networks like Starlink, for example, bridging that gap in many cases, other licensed and unlicensed fixed wireless networks, you're seeing technology solutions, being brought to bear to some of those areas. So I think that's changed the equation a little bit, and it will be exciting, particularly looking at LEO networks as more of those networks become available. How does that change things, to people that are in very rural areas, maybe even off power grids?
Anyone else would like to?
Yeah, I would like to touch upon the question we had on community networks and whether they represent an alternative to traditional telcos. I would say to some extent, yes, to some extent, because traditional telcos are not necessarily interested to, expand their services in those far away places, rural places, and the only option usually that are available to the community there is to actually build their own infrastructure, and using commodity devices, one can easily build a small network and run some services. And actually, the aim of a community network might be a little bit different from a traditional ISP, because they would mostly focus on perhaps local empowerment, having extremely affordable services, and having services that are more related to what the community are looking for. So you can call it like community-centric services. And the whole idea and the whole paradigm, I would say it's all about digital inclusion and things like that. So maybe the model is a little bit different from traditional telcos, but I guess equally important especially in areas where the telcos are not present.
It's a good point. And one quick, note in response, I think sometimes communities are very focused on the initial physical build of that network and what it takes. And sometimes the hardest thing is really the ongoing maintenance and support and upgrade, maintaining good security posture, fixing, outages, those kind of things. And sometimes that can be an afterthought, but it's oftentimes the most complicated part after the physical build.
Yong, would like to add something to the question?
Actually, I don't have much idea to say on the community network, but recently there are a lot of deployment on the edge computing. So for the edge computing, we are searching some killer applications for this kind of edge computing. Some maybe the gaming companies would like to use the edge computing to reduce the latency between the client and their servers. So maybe that is some kind of the new future.
And Nat, if you allow me ask a follow-up questions about the first answer in terms of the other. Jason, you mentioned two things, wireless and problems, and say that there are solutions that the ISPs are providing to the customer to do that. And Yong also mentioned latency, one of the several problems besides the DOS attacks, etc. But latency is it's known by the application, so the ISP has less control on that. Amreesh, your problems are pretty much similar to other countries. In Brazil, manpower is a problem, so we can. But anyway, let's start from those two, latency and wireless. What solutions do you provide? This is related also to the second questions, but what you envision? Do you perform constantly measurements for that? Do you exchange data with applications and to improve latency, for instance? And what about wireless? Can you say something about it?
Sure, I can speak to both those things. So first, I would say on the wireless or Wi-Fi LAN side of things, there is a huge difference between application QoE if you have great Wi-Fi versus if you just sort of have average Wi-Fi. And a lot of people have very old equipment in their homes, and they sort of take the approach of, if it doesn't break, like stop working, I will not replace or upgrade it. Instead of thinking, oh, Wi-Fi 6 is out and I'm going to upgrade to that sort of, version and so on. So a lot of ISPs now have a wireless gateway that they provide to customers. And importantly, apart from having things like smart sort of radio management technology where it can look at adjacent SSIDs and what channels they're on and dynamically change things to find non-overlapping channels, they also offer mesh networking, so you can sort of have these distributed access point pods throughout the home. And optimally, you would use Ethernet backhaul there rather than Wi-Fi mesh backhaul to get better performance. But those are important, and I think that there's a whole area of innovation around tools to help users, whether through apps or other things, sort of navigate what's the best place to put those things in the house, and how can I do things to improve the network in terms of wireless performance. But really, latency and working latency performance is the next forefront, I think, of network innovation. The IETF just standardized L4S, which is low latency, low loss, scalable throughput, and are on the cusp of standardizing the next part of it, which is NQB, non-queue building per hop behavior. Both of those things are a mouthful, but they work in two different ways. One, in both cases, the application is tagging their packets. L4S uses the ECN header, and basically uses ECT1 or CE marking, which is pretty straightforward and works today end-to-end across almost every network around the world. The second is NQB, which uses a DSCP mark, DSCP 45 in particular, and that doesn't really work. And that goes to one of the earlier QoS mapping questions. Today it is very exceptional that DSCP marks work across network boundaries. Most people just use DSCP marks within their own network, and they don't really overlap. So DSCP 45 is intended to be really the first interdomain DSCP mark that people are agreeing on. We just did an end-to-end test with NVIDIA of that mark, which is sort of the first time that we allowed DSCP marking to pass across a border without getting bleached. But in this case, the way or the reason that that gets used is that there is now at bottleneck links a second network queue being created that has a very shallow packet depth or buffer depth. And so if an application tags their packets for L4S or NQB, it goes into, say, in the CPE or in an edge router, that separate queue. It has a really shallow buffer, and so the real-time traffic performance is much, much better. And so we're in the middle of field trials of that technology, and it's pardon the pun, but a game changer for online gaming, cloud-based gaming, and other kind of AR and VR experiences. So I think there's a lot of innovation to be found there, and that's where a lot of the network research has been focused by a number of researchers the past few years.
Thank you, Jay. Yong, could you add something about what are the main issues and solutions to those?
Yes, so about the latency, I think there are different fields of the latency first. For example, I think the distance between the client and the server that we can call the layer 1 latency. So the solution could be some kind of edge computing or maybe CDN. And we can also think about the layer 2 latency. So that is called maybe a protocol for the shared access, like some layer 2 protocols. And we also need to consider some maybe a layer 3 or layer 4 latency, that is including the retransmission latency. And for the applications, we also need to consider the QE, which is very different to the just latency, right? So for example, the link latency, we need to maybe focus more about the bottleneck, like the links between different operators. So that will be the bottleneck. And for the QE, I think maybe the most important applications could be the video transmission, right? But when we consider the video transmission, I think a very interesting problem is the fairness. So although we design TCP or something like a congestion control with fairness, but in reality, some video company, right, they send the packet without fairness. They try to maybe send the packet as much as possible. That is totally different to the academic research. So in that case, without the fairness, maybe the latency with some other applications could be a very big issue. And I think maybe we will have a quick protocol. And IETF also set up a new working group named MOQ, Multimedia Over Quick. So in this quick protocol, everyone or maybe the application company will be easy to write their own congestion control algorithm. In that case, the fairness could be a very important issue in the near future. That's all.
So, thank you. And Amreesh, I think some of the situation in Africa, it's pretty similar to other countries as well. And let's say Jason mentioned sophisticated tools to improve connectivity. I imagine that those solutions cannot be brought to many areas in Africa, say, since people do not have the means to pay for that. And also, how do you? Well, we can talk about manpower later, I guess, in the other question.
Yeah.
But how do you deal with because people cannot pay that much to allow sophisticated solutions in the market, probably that
Right.
may create an issue. That am I
Yeah.
correct?
Yeah, again, it would depend on the market within Africa itself. Maybe the well-developed markets might be able to pay for those services and optimize to the maximum the issues of latency on the land level. But I think the issue in most of the African countries is still on the one side of things where there is a deficit of peering. First of all, the building of peering fabric within the countries is very timid, right? And some countries might have ISPs, some have ISPs before and then stop having ISPs because the community, it didn't work out for them, and they have pressure from the traditional incumbent operators, and sometimes regulators would want to come into the peering field, trying to regulate things, which would, in some cases, discourage the local community to actually run a peering infrastructure. So the lack of peering, the consequence of that is that two networks between the same country, when they need to communicate to each other, it needs to use international bandwidth, and this adds to the latency, of course. So you might a good example is accessing e-government services within a country in Africa is sometimes very, very slow because you might not be on the same network as the government services are, and therefore you're using an international link to reach services that are essential for the day-to-day operations and day-to-day activities of citizens. So yeah, I would say lack of peering. The fact that there's a lack of peering, so there's no incentive really for carrier neutral data centers to come and set up, and therefore there's no attraction of big content providers. So the relationship between the content providers and the CDNs are mostly directly to the ISPs in most of the cases, which means that maybe a competitor would have access to that cache themselves because they are in a different network.
So, thank you. And Matt, do you like to ask a question, perhaps from the audience before we go to the next round of questions? As any?
Yeah. There's several good questions from the audience. Let's see. One is about quality of service again, and how that pertains to peering across ISPs. How do ISPs handle peering arrangements in general between them, especially mapping quality of service, if quality of service criteria are applied within their networks? How do quality of service classes and parameters get carried in other ISPs? Or if you have any other thoughts on how peering can be done with respect to preserving quality of service, that would be helpful. Are there any thoughts on that question?
So basically preserving clause marking across boundaries is, the core, I think. In most cases, I don't think ISPs or just different networks honor those markings. They typically get bleached on an inbound basis. So as an example, like if we're sending packets to another network, they may have our various different DSCP marks, but the other network, as soon as they receive the packets, it's going to strip those out because they may be using the same markings, but for different purposes in their network. So it's very hard to do. But apart from the one DSCP mark that I just mentioned that's getting standardized for non-queue building traffic, DSCP 45, I feel to a certain extent that DSCP marks, or sort of quas in general, is predicated on the notion of scarcity of bandwidth, because in many cases, that prioritization only matters when you've got congestion, you have insufficient capacity. And I just don't see that situation very often at interconnection points. It's really the opposite. There's a lot of connectivity, a lot of bandwidth, and it's really only when you have a natural disaster or fiber cut or something like this that really becomes an issue, but that's usually pretty exceptional. So, I think we're kind of in this era where we're trying to get, at least, in some of the discussions at IETF and elsewhere, to get people to shift their sort of network mindset from this mindset of scarcity of capacity and contention into one where you have abundance, but certain applications aren't getting the latency, treatment that they really need. And so how do you achieve that?
Okay, yeah, that's very interesting. Yong, Amreesh, do either of you have thoughts on this question?
Yeah, I also agree with Jason. I think in the large ISP network, it is very difficult to use this DSCP field, especially for the data packet, and it is also very difficult to make the negotiate between among different ISPs, right? So the large scale ISP just try the very simple philosophy, just make the best effort.
Yeah. Amreesh, do you have any thoughts?
I would agree to what Jason and Yong just mentioned, and I guess QoS is something which is becoming more and more important to the end users, especially those in the gaming field and everything, where they need very low latency services, stable quality of service. So especially this is critical for I would say critical infrastructures running on the internet. I don't know if there are monitoring of QoS systematically in those type of environment. That would be interesting.
Yeah, great. Okay, that's helpful. We had another question as well. We wanted to ask you if you're integrating large language models into your operations. Do any of you see that with the companies you're working with? If so, in what areas? If you could also speak more broadly about AI's potential to revolutionize networking or your operations, that would be helpful as well. Do any of you have thoughts on that?
Sure, I can go first and offer some thoughts. One, I would say there's a lot of experimentation, in the use of AI and large language models in particular. I know in the area of sort of customer care and being able to sort of chat with a customer, that seems like a really advantageous situation that you could use LLMs. And I notice, just with OpenAI's ChatGPT, oftentimes if I type in, say, my DOCSIS modem RF levels and ask it to suggest what to do, it gives me a pretty good answer. It's looked at SCTE papers and other kind of papers and tells me, oh, you have this impairment and you should do, this as a solution, which is kind of cool. So I think that you'll see some, customer interaction kind of things, take advantage of it. But I know from a network engineering standpoint, there's a fair amount of use of this in our network. In particular, we deployed it at the beginning of COVID. We have a system called Octave, and it's basically an AI model that gets used internally to look at basically our RF spectrum that we use, and looks at a bunch of polling data that's collected every hour, and dynamically shifts people around to different parts of the spectrum, modems around to different parts of the spectrum. And it enabled us really just with software to find about a 30% increase in upstream capacity during the beginning of COVID, which was huge because, it was basically, finding underutilized capacity and being able to dynamically shift devices around without having to go out and, deploy new fiber in those, first few weeks of the pandemic. Of course, that was happening as well, but it was an immediate thing. And so, it can help, I think, find network capacity and sort of spectrum management, making that better. It can help in detecting situations before they become outages. So when you start to see a degradation and you're like, okay, this pattern we've seen before, and in another 10 days, it will cause an outage, but we're catching it far upstream. And so we can do these 3 or 4 things to go solve it before it's customer noticeable. And so sort of, other related things, mean time to detect an outage, mean time to repair, those kinds of things help tremendously. So I think that there's a lot of, I would say it's the sort of unsexy network reliability and performance things that there's some interesting applications.
Okay, so in my opinion, maybe we need to consider this question in 2 aspects. One is the backbone network, and the other one is the cloud network. So for the backbone network, we need to consider the vendor and the equipment, right? So for I know some of the vendors are just working on some kind of computation card into their big boxes. So with this computation card, maybe we can use some kind of simple machine learning algorithms. But without this kind of computation card, it will be very difficult to use machine learning on the equipment. But another opinion is to use the machine learning on the operation system, right? On the network operation system that can be used, but consider the very basic requirement of the very high availability. So the operators, generally speaking, is very careful to use this kind of machine learning technologies on their big ISP network operations. But on the cloud, because some operators just use the white boxes, that will be easy for them to upgrade the algorithms into the boxes, and also will be very quick to adjust the new technologies in the cloud network. So that will be easy to use the machine learning and maybe also the large language model. Yes.
Yeah, that's great.
Yeah. I guess the application of AI in the management of network is quite obvious, and this is coming, if not already happening, in many big networks today, especially with regards to bandwidth management and things like that. So but I think the large language models, if we want to stick to that concept, so because it needs to process large amount of textual information, I think where it can be helpful is in troubleshooting network anomalies, because it can process large amount of network logs and maintenance reports and technical documentation, and this can help perhaps engineers to easily pinpoint the problem, because the AI system has the large language model has processed so much information. The other application of LLMs, I would think, would be on the business side of things, where ISPs would do market research and analytics based on vast amount of information that has been collected from various sources, market research and customer behaviors and things like that, and actually extract trends or predictions from that, I believe.
And Matt, if you allow me act as an audience, we'll follow up a question for you. AI in general, except let's say customer behavior, but anyway, in general needs a lot of data collection. You have a large database to be able to do. You guys, or perhaps the first for Jason, do you collect your own performance availability measurements and also from time, and then for Yong and Amreesh, do you also see the large language models or AI in general as a tool to help, let's say, to get people to understand more of the problems, to train people? That's the correct word, to train people. As you, let's say, Amreesh mentioned the lack of people to train that and to use as a trainer for networking. So yes, the first one for Jason.
So using all this data to train the models or to train people?
First of all, to train the models.
Yeah. I mean, it is good. It's a good example, I think, because there is just a massive amount of data that you have about network performance, so massive that people really can't look at it and analyze it thoughtfully. It's just like this avalanche of data. So it does seem to have an intriguing possibility to help navigate that and find the interesting patterns, for sure. So I think that's a great example. And then, training people, I think, is a different issue, probably more complicated. But, there was one question in the sort of speaker Q&A about training and sort of the skills that you need. And, just to maybe touch on that, oftentimes maybe in the past, you've had this difference between sort of classically trained network engineers, if you will, and software developers. And they were sort of these two different things. And I think increasingly the kind of people that are great to hire and train are people that have skills in both areas. And we really expect, network engineers, people that work in the network today, to have development skills, to be comfortable using GitHub and contributing back to an open source project that we're using in the network, or writing, detailed scripts or debugging some of these code. All those things are important skill sets. So I think the dividing line between those two disciplines is really softening.
Okay, so in my opinion, to train model is quite important if we would like to use this kind of machine learning models in our networking scenario. But when we train models, I think maybe we need to think two questions first. So which kind of model are you going to use in the network? I know some companies use AI ops, for example, to operate their network and to find the main root cause for some kind of alerts, right? But that is maybe only work in a company network or enterprise network. But for large scale ISP, I don't find the very popular AI ops. So that is the first thing. And the other thing is, for example, we need this data set. But for the academic research, it is very difficult to get the data set from a large ISP network. So that is two aspects. One is the final usage scenario, and the other one is the data set. And for the maybe training the people, I think there are some research on the digital twin network, but it is still far away to be realized on the industry network. Okay.
Thanks. Amreesh?
Yeah, I would perhaps raise a point of caution on the use of large language models. So are we talking here about generic large language models or very specialized ones for specific tasks, right? So let's imagine like tomorrow a big networking equipment vendor decides to create a large language model, and this large language model is actually shipped with equipment or whatever to all the clients around the world. So, and maybe an African operator might not have the same issues like someone in Europe or in the US, right? The network, the attack patterns they are receiving might be totally different, and the way the model has been trained, let's say in Europe or in the US, might not be applicable to other places. So maybe we need to segment the problem a little bit more, and try to see what exactly are we trying to tackle. Maybe just a generic large language model for everything might not work.
Good. Matt?
Yeah, I could ask another audience question. Let's see. Are you able to talk about the modern network edge of ISPs? Do you use network microservices at the edge? Are edges programmable? Are there micro clouds at the edge or edge computing? Or do you see any of that sort of thing in companies you interact with? I'm not sure if you're able to talk about that sort of thing.
I'll go first and sort of joke which edge. Yeah, I would say you have a few things happening. One, interconnection is getting ever more local. So whether those are cloud providers in particular, but classic CDNs and others, if you went back 5 or 10 years ago, they might have been connected to an ISP backbone in 5 places, right? And now they're increasingly connected in a dozen or 2 dozen or more local regions or cities to reduce that round trip time and get that content as close to users as possible. As network operators have started to decompose their sort of software stack and the equipment, and virtualize those platforms, it creates an opportunity to do sort of edge compute and edge caching and move that even closer, sort of one hop away from the initial point of access network aggregation. And that's sort of inevitably where things are going. And really, I think the future, because the compute and storage has gotten so cheap and small, doesn't use a lot of power. And you've got, access network platforms that have become virtualized and are running through basically servers, and so there's a real opportunity to do that. So I think there's a lot of exciting things that'll happen there, and you'll see these sort of boundaries between networks and service providers really blur, which will be great for end user applications. I think there'll be some really cool development.
So to my opinion, we still need to maybe classify this question into 2 different scenarios. One is the backbone network. In the backbone network, we just operate the maybe big black boxes like Cisco routers. In that case, it is impossible for us to use this kind of microservice. But in another aspect, in the cloud, we can use microservice because all of the network service could be the NFV. In that case, that will be much easier for us to use microservice. Yes.
Yeah, and I think a perfect application of that would be the metaverse, right? Because you need the edge compute and a lot of processing happening on the edge, closest to the end users. So I think if ever the metaverse becomes like the next big thing, a lot of the current model of content delivery might change, and we need to adapt to the demand in that regards. Yeah.
Matt, can you go to the questions about students?
Yes, we had a question about students, what you look for when you hire students. When hiring, do ISPs prioritize candidates with a solid foundation in computer networking, or is it focused predominantly on programmers? What skill sets do you look for in students when they graduate? Do you have any suggestions for educational institutions about how to train students, and so on? Do you have any thoughts on that?
I think I mentioned a little bit before, which is it's always good for people that want jobs in the network sort of discipline, if you will, to also have some software skills and be able to do those sorts of things. So I think that would be that's sort of one recommendation. That's increasingly a type of folks that we hire, and people that also tend to be sort of hobbyists, home hobbyists with networking and servers and sort of things. Those people often get a leg up. So, they might have a really interesting home network that they've built, or they're experimenting with devices and these kind of things. And that's always a good thing to see. You like to have people that like to experiment and use that as a tool to learn by doing things in their home network or in their computer lab at school.
So in my opinion, maybe for the undergraduate student, maybe we need to consider about the programming skill. For the vendors, they like C or C++ programming skill. But maybe for some operators, they may just focus on some kind of Python or maybe upper layer programming skill. That is different, I think. And for the master or PhD student, maybe it is very important for academic to have a very deep understanding of the current state and the requirement of the practical applications, because some of the PhD student just read some papers and to find some maybe a small bugs and to write new papers, but these student do not know much about the real world. So even they publish very good papers, but the assumption is totally different to the real world. So the operators or the vendors cannot use their innovation. So that's a very big pity. And additionally, maybe we also hope the student to know not only the networking technology, but maybe also some kind of upper layer service like QoE. What is the relationship from QoE to QoS, to know some kind of deep dive to the major services. That is quite important to optimize the network itself. Yes.
Yeah, I think the question of training is quite an interesting one. So I've heard from both academics and the industry. So the academics would always want to focus on the theoretical aspect, making sure the students have the right groundings in computer science and everything. And on the other side, the industry, when they get those students, they say, oh, there's a gap. There's a gap in all the new technologies or all the new fancy stuff that they need people and hence to be working on. And so whose role is actually to bridge the gap? So there's always that tension in between those two. And I've also heard some industry people, some ISPs, when they are looking for very specialized manpower, they run into the issue where they do not have students that were trained properly in the fundamentals of computer science, because they do not know how to process packets. They only know how to do high-level stuff on tools that were built to do things for you easily. So yeah, there's always a tension, and where you find a middle ground is a little bit tricky. But I guess there need to be constant interaction between the industry and the academia.
Okay, that's great. We wanted to ask one more question about virtualization. Are you able to talk about how you see uses of virtualization in your companies and companies you work with? Regarding the edge comments that were made earlier, are ISPs getting virtualized, and so backbone networks are kind of just getting reduced to fat pipes? Does virtualization make load balancing harder because you can't see inside packets as well? Do any of you have thoughts on that question?
Well, I think networks have had to get a lot more creative in doing traffic analysis. I think the real big driver for that was pervasive encryption. So if you look at, Google or Firefox's stats publicly, at least on the web, something like 96 or 7% of user time on the web is encrypted. So, there's no, sort of DPI-like panacea to see lots of detail about network traffic. You can tell things about flows, what are the destinations using IPFix or NetFlow. You can do some additional analytics, but even some of the tools that depend on FQDN, that's eventually going away with encrypted client hello. So really all networks will eventually see is source and destination, and maybe some of the underlying protocols like TCP or UDP. So, that is having to get more sophisticated. There are a lot of, people working to develop, analytics, tools in that space. So the visibility of traffic is changing, and some of the associated network management has to get more sophisticated as a result.
Yeah, Yong, do you have any thoughts?
Yeah, so in my opinion, when we hope to inspect the flow of the packet, especially in the larger ISP network, we have to use some kind of X flow or maybe net flow. In that case, we just select maybe one packet among more than 1,000 packet. So just 1 to 1,000, and in that case, with this the selection, random selection, we can analyze the maybe, for example, the DDoS attack or some other security issues. But in that case, the efficiency is quite slow. Maybe we just have 1 minute latency about the DDoS detection. So that is one problem.
Sorry, I might have missed the question. What's the question about virtualization?
Yeah, just generally about virtualization. Do you see people using virtualization? Does it cause any problems like affecting load balancing, or where is it deployed? How's it used? That sort of thing?
Yeah, well, unfortunately, I have very little insights about whether it affects load balancing, but my gut feeling would be that virtualization would be a very natural step into the evolution of how network services are handled. We have seen virtualization in many other spheres, so it's bound to happen to some extent. And obviously, it comes with all a series of problems of efficiency and orchestration and all those type of things, which I guess probably are good food for us academics. Yeah.
Great.
Yes,
Okay.
Yeah. Out of time, right?
I think so. Yeah, thank you everybody for joining. That concludes the panel. We want to thank the panelists for their great insights and putting together such an interesting event. We're going to have a recording of this up on YouTube. It's going to be linked off of our webpage. We want the conversation to continue. You can join the Slack and keep asking questions of the panelists, and they'll try to answer when they can. If you're able to join our next event, we're going to have an event on December 13th on low Earth orbit satellite mega constellation systems. Should be very interesting. And with that, thank you very much for attending, and we look forward to seeing you at the next event. Thank you very much.
Thank you, everyone.
Bye.
Really nice panel. Thank you. Thank you very much.